Hello guys, welcome to Green Academy. Let's discuss a question based on projection of lines by line rotation method. The top view of 75 mm long line AB measures 65 mm, while the length of its front view is 50 mm. Its one end A is in the HP and 12 mm in front of VP. Draw the projections of AB and determine its inclination with HP and VP. Also mark the traces. So this is our question. We are discussing a line rotation problem by very easy method. The method I am going to follow is a very easy method. The first step is we have to draw the basic figure of line rotation question. Okay, there is a basic figure, so first we have to draw the basic figure. Then the next step is we have to compare our question with this basic figure. Okay, now let's draw the basic figure first. Okay, this is our basic figure. First is draw an xy line. This is our xy line. Suppose there is a line which is lying on first quadrant and it makes an angle with both HP and VP. Okay, the first step is we have to make the line parallel to VP and draw the front view and top view. First we have to fix one point. Suppose the name of the line is AB. The name of the line is AB and I am fixing the point A. Suppose the A is some distance A dash. This is the front view of A and this is the top view of A. Okay, this is some distance, say some x distance or y distance from xy line, because it's in the first quadrant. The front view will be in above xy line and top view will be in below xy line. Okay, this is our front and top view of our point A. The first step is we have to make the line parallel to VP and draw the front and top view. Suppose it's got a true length. We know the true length. This is our line, front view of the line when parallel to VP. So suppose this is B1 dash or B1 prime. So this is our true length. Suppose we know this length and we know this angle. What is this angle? This angle is called theta. Okay, inclination with HP. And we know the line length of the line and we got this locus point. Okay, so draw the locus point. Locus point is M dash. Okay, and the projection of this point, projection of the line when parallel to VP and inclined at an angle theta with HP. This is front view. And what about the top view? This is our top view, right? This is V1. This is our top view because the line is parallel to VP. That's why it's parallel to XY line and we got a reduced length, right? And the next step is again we have to rotate the line and make the line parallel to HP and inclined to VP. Parallel to VHP and inclined to VP. Suppose this is our true length. We know the true length and also we know this angle. This is phi. Phi is the angle that makes with vertical plane. Okay, suppose this is true length and this is our V2 and this is our locus point. The locus point is MM. What about the front view when the line is parallel to HP and inclined to VP? You have to draw a projection and this will be the front view of the line when it's parallel to HP. This is B2 dash or B2 prime. Okay, so how to find out original front view and top view? We already find out the length of the original front view. This is the length of the original front view and from here to here AB1 is the length of the original top view. This is only the length, not position. How to find out the position? You have to transfer this length from here to here. Just transfer the length from here to here. Take a compass or measure the distance. Take a compass and draw the arc. So we got the original top view AB dash. This is the original front view. Sorry, not top view, front view. Original front view. And what about original top view? We already got the length of the top view. Just you have to just transfer this length from here to here. This is our AB. Okay, this is our front length, this is our front view and this is our top view. and this front and top view, that will be in the same line, right? It will connect the line in a parallel way. So this is our basic figure, right? This is true length, this will be true length, this is reduced length, and this is reduced length, this one. And this length will be equal to this length, and this length will be equal to this length, correct? It's not an exact figure, that's why it looks like different length, but actually this length is equal to this length, and this length is equal to this length. And what about alpha and beta? This is alpha and this is beta. Inclination with HP is called theta, and inclination with VP is called phi. Okay, and what about alpha and beta? Alpha is inclination of the front view with XY line. Inclination of the front view with XY line is alpha. Inclination of top view with XY line is beta. Inclination of the line with HP is theta. Inclination of the line with VP is called phi. That is the difference between theta and alpha. Okay, so this is our basic figure. The next step is you have to compare our question with basic figure. The top view of 75 mm long line, 75 mm long line, the length of the line is given. So this true length, we know the true length, so true length is given, and its top view of 75 mm long line AB measures 65 mm. Its top view 65. That means what about this top view? Top view of a line, that is 65 mm. This is the top view of the line, 65. This is 65 means this is also 65. Okay, this is true length, that is also given, that is 75. While the length of its front view is 50 mm. Length of the front view also given. This is the front view, length of the front view is 50. So this is 50, then this also 50, because these two lengths are same. Its 1 and A is in the HP and 12 mm in front of VP. So 1 and A is in HP. So 1 and is in HP and in front of VP, some 12 mm. That means the line is in the first quadrant. Okay. Draw its projection of AB and determine its inclination with HP and VP. We have to draw the projection of the line, and we have to find out inclination with HP and VP. What is inclination with HP and VP? Is it alpha and beta or theta and phi? So here inclination with HP and VP means theta and phi. If the question is like inclination with XY line, then we have to find out alpha and beta. Here also we have to mark the traces. Okay, this is the point A is in HP and 12 mm in front of VP. That means in first quadrant. Can you spot the point A? Yes, of course we can spot. This A is in HP, so this is the front view. Front view itself in XY line, because the point line is in HP itself. So this is A dash and 12 mm in front of, this is 12 mm. Suppose this is 12 mm in front of VP. So front top view will be below XY line, and then the first step is we have to make the line parallel to VP and incline at an angle HP, that is phi angle with theta angle with HP, and we have to draw a front view and top view. Do we know the length of the true front view? That is true length. Okay, the first step is here. The first step is we have to make the line parallel to VP. So this is the front view, and we have to draw the top view. This is the top view. The true length is given, right? True length is given. And can we draw the line? No, because we don't know the angle, it's theta. Okay, we have to find out the angle. Can we draw the front and top view? Yes, we can draw the front and top view. How? We know the distance. The reduced length is given, that is length of its top view. This is 65 is given. When this is 65, this also 65. Okay. We know the top view, right? Can you draw the top view? Yes, top view will always parallel to XY line. So just draw a parallel line and measure 65. And measure 65. This is our what? This is our A, not B. This is our B1. Okay? This is our B1. So we got this line. This length is 65, right? And then what about this projection? Can we draw this projection? Yes. This projection, just draw a perpendicular. This is our projection line. And how to draw this true length, this front view, true length front view? Do we know the angle? No, we don't know the angle, but we know the end point. This end point must be in this line, right? endpoint must be in this projection line. So we already draw the projection line, and we know the true length. That is, true length is how much is 75 is true length, correct? So we have just take a 75 from your compass and mark an angle, cut this line, okay, because we know one of its line is passes through this projection line B1 dash, correct? One of its end is in the projection line, okay. This is our 75, so this is our true length 75. So we got this point. Just immediately draw the locus point, locus line, that is m dash. This is our locus line, okay. What is the next step? Make the line parallel to here, make the line parallel to HP and draw its top and front view. We know the true length, but we don't know the angle phi. How to draw its top view and front view? Do we know the length of the front view? Yes, we know the length of the front view. Here we know the length of the front view. It's 50 given. When it is 50, this also 50, because the length is same. Okay, we know the length, that is 50, and the front view is definitely parallel to XY line, right? Because the line is parallel to HP. The line is parallel to HP, that's why its front view is parallel to XY line. We already know the length, so this is our A dash. It's in the XY line itself. So measure 50. Suppose this is 50. This is our point B2 dash, right? This is our point. This is 50 B2 dash, and then we have to draw this projection. Next step is draw this projection to draw the perpendicular. This is our projection. And how to draw the true length? We already know the true length, and we got the line, that is the other end B2 must be in this line, that means in this line. So we know the length. Just take the 75 mm and make a cut. This is our B2. Draw the focus line, locus line, and we got the front view and top view when the line is parallel to HP and parallel to VP. And how to draw the original line? Just transfer this length 50 mm from here to here. Suppose this is a 50, this is our B dash, original front view, and just transfer this line from here to here. This will meet at this point. This is B, okay. This is our original top view. This is our original, this is A, original top view and original front view. And we have to find out what theta and alpha. Measure this angle. This is theta and this is phi. What about alpha? This is alpha and this is beta. And the final part of the question is we have to mark the traces. Traces, just extend the front view, find out the point at which it meets at XY line, that is H dash. So the line itself in the HP, so this is H dash, this point itself H dash, and draw a perpendicular and find out the point at which the perpendicular meet with the top view, extended top view. So here HT, and then here we have to extend the front view, top view. This is V. Also we have to extend the front view. This is VT. This is our vertical trace, and it is horizontal trace. And the point and A is in the HP and 12 mm in front of VP, and A is in HP. Okay, A is in HP. So this is in HP. This is A dash and 12 mm in front of VP. Mark the 12 mm. This is A. This is 12 mm. And first we have to make the line parallel to VP and draw the true length. We don't know the here we don't know the angle theta, so but we know the front view, top view of 75 mm long line measures 65, so its top view is 65. Just draw a parallel line. Draw a parallel line parallel to XY line. This is a line parallel to XY line, okay. and measures what is the length of the front view. It measures 65 mm. Okay, 65 mm. This is 65. This is 65 mm. We got this front view, top view of the line when parallel to VP and inclined to HP. So this is B1. Okay, then draw the projection line. This is the projection line, exactly like this. Okay, we have to draw the projection line. We have to draw the projection line and mark the true length. Okay, what is the true length? True length is 75. So take 75 in a compass. Okay, 75 in a compass. Okay, this is 75. Okay, 75 and mark here. So arc at an arc. So this is our true length. Okay, draw 75. This is our true length 75. Okay, so we got this locus line. Immediately mark the locus line. Locus line is very important. So this is M dash or M prime. Okay, then next step is we have to make the line parallel to HP and draw the front view and top view. Okay, parallel to HP. So we will get true length in the top view, but we don't know the angle phi. So how to draw this top view? We know the length of the front view. What is the length of the front view? Is 50 mm, right? What is the length of the front view? While the length of the front view is 50 mm. So here length of the front view. Here the length of the front view, this is given, right? This 50 means this also 50. Okay. So here the line is parallel to, line is lying on HP. That's why, so here you have to measure 50. So this is 50 and this point is B2 dash and draw the projection line. Draw the projection line. This is our projection line, and from here to here mark our true length 75. So this is true length. We already measured this. Okay, this is 75. From here to here you have to cut an arc of 75. This is our locus line. Please draw the locus line. Locus line is M, and this point is B2. This is our true length 75. True length 75. So we got our front view and top view when the line is parallel to VP and parallel to HP. So next step is you have to find out the front view and top view of the original line, that is reduced length. We already know the reduced length. This is the reduced length of front view. Okay, and how to find out the position? Just transfer this point from here to this focus line, locus line. Okay, so here this is our front view of the line A dash B dash, and this line will be draw the projection from this point. This is the projection. Okay, it passes through this point. That's our B. Okay, so this must be, when you transfer this front view from here to here, it must passes through this point. See, this is our, when you transfer this length from here to here, It must passes through this projection line. Okay, this is our top view B. Okay, next you have to measure this angle. This angle, what is this angle? This angle is theta. And what about this angle? This angle is phi. What about this angle? This angle is alpha. And this angle is beta. So you have to measure the angle theta, phi, and draw and mark the angle here, and alpha and beta, and make a box, put it in a box. Okay, then what next is mark the HT and VT traces. So here the front view, the line itself touching its XY line. So this is our H dash and this is HT. You need to extend this front view, this from reduced length, and also extend the reduced top view. Find out the point at which it meets with XY line. This is our V. Drop a perpendicular. This is VT. So we already measured. So you have to measure V and V, this distance VVT and H dash HT. This is our HT and VT. So next part is dimension. So dimension, we already know this distance. So mark the distance. This is 12 mm. 12, and this is true length, right? We take an arc. So what is the radius of the arc? R75, right? That's why this R. Here also this length, this is R75. Its radius is 75, right? If you have any doubts regarding this topic or this problem, just ask in the comment box. Okay, thank you.